Hello everyone, welcome to Dr. A classes for BTech students. In this lesson today, we'll explore the concept of precipitation, its significance in the Earth's hydrological cycle, and its impact on water availability, agriculture, and civil engineering planning. We'll discuss its forms, factors influencing its occurrences, the processes behind its formation, and instruments used to quantify. Understanding hydrology is crucial for civil engineering students as it plays a key role in water resource management, flood control, irrigation planning, and sustainable development. So let us begin our journey into the science of water. Learning objective of the course is defining precipitation and explaining its significance in the hydrological cycle, understanding the atmospheric conditions necessary for precipitation to occur, explaining methods of precipitation measurement, analyzing precipitation data for hydrological and engineering applications, applying precipitation data in water resource planning and design, interpreting isohydral maps, and understanding spatial variability of precipitation. What is precipitation? Precipitation is any form of water, liquid or solid, that falls from the atmosphere to the Earth's surface. It is a key component of the hydrological cycle, supporting life, recharging groundwater, and driving climate and weather systems. Without precipitation, no part of the Earth's surface would receive fresh water from the atmosphere. Precipitation is essential for water availability, agriculture, and engineering planning. Precipitation in India. India's rainfall is predominantly seasonal, with nearly 75% occurring during the southwest monsoon from June to September. This is crucial for agriculture and replenishing surface and groundwater resources. India also receives rainfall from the northeast monsoon during October to December, particularly impacting Tamil Nadu and southeast coast. Geography plays a huge role in rainfall distribution in India. Orographic effects due to the Western Ghats and Himalayas lead to high variability. For example, Meghalaya gets some of the world's highest rainfall, while Jaisalmer in Rajasthan receives very little. Understanding rainfall pattern is crucial for planning for irrigation, reservoirs, flood controls, and drought preparedness, which are vital aspects in civil engineering and water resource management. Forms of precipitation. Precipitation occurs in various forms depending on atmospheric conditions. Rain is the most common form and varies in intensities, light, moderate, or heavy, based on the rate of fall as described. Snow forms when temperatures are below freezing, resulting in soft flakes with low density. Drizzle consists of smaller droplets and lower intensity than rain. Glaze happens when supercooled droplets freeze upon contact with surfaces, forming a smooth ice layer. Sleet is made up of small frozen raindrops, often bouncing when they hit the ground. Hail consists of large ice pellets, usually forming in clouds during thunderstorms. Each type has implications for hydrology and infrastructure design, especially regarding drainage runoff and structural load. Factors influencing precipitation. Precipitation depends on various atmospheric and environmental conditions that control cloud formation and moisture release. Factors that influence rainfall are moisture content. More water vapor in the air increases the potential for precipitation. Air temperature affects condensation and determines whether precipitation falls as rain, snow, or other forms. Topography. Mountains force air to rise, cool, and condense, leading to orographic rainfall. Air movement. Rising air currents enhance cloud formation and precipitation. Atmospheric pressure, low pressure, encourages air uplift and precipitation. High pressure usually leads to dry conditions. Frontal activity, interaction of warm and cold air masses cause precipitation along fronts. Wind pattern transport moisture and influence cloud formation. Condensation nuclei, presence of dust, pollen and other particles are essential for droplet formation. Formation of precipitation. Precipitation forms through a sequence of atmospheric processes beginning with water vapor and ending as rain, snow or other forms falling to earth. Key stages in the formation of precipitation are evaporation. Water from oceans, lakes, rivers and plants rises into the atmosphere as water vapor. Cooling and condensation. As the moist air rises, it cools. Water vapor condenses into tiny droplets around condensation nuclei like dust or pollen, forming clouds. Droplet growth. Cloud droplets collide and coalesce or freeze and grow larger through processes like ice crystal processes. Precipitation falls when droplets or ice crystals become heavy enough, they overcome air resistance and fall to the ground as precipitation, rain, snow, etc. Formation of cloud. Clouds form when moist air rises, cools and condenses. The rising of air occurs due to the following mechanism. Frontal lifting. Warm air rises over cold air. Orographic lifting. Air ascends over mountains, cooling and condensing. Convective lifting. Air is heated, rises, cools and condenses. Convergent lifting. Winds converge and push air up, causing rain. Frontal lifting. Frontal lifting occurs when air masses of different temperature meets. Warm air is lifted over cold air along a front, either warm or cold, leading to cloud formation and widespread precipitation. Examples. In northern India during winter, cold air masses from the northwest, like western disturbances, meet warm air over the plains. The warm air is forced to rise over the cold air, leading to cloud formation and light to moderate rain. Orographic lifting. When moist air is forced to rise over a mountain range, it cools and condenses, causing precipitation on the windward side. Leeward side often remains dry, creating a rain shadow effect. Example, in India, moist monsoon winds from the Arabian Sea rise over the western Ghat, cooling down and cause heavy rainfall on the windward side. Convective lifting. When the Earth's surface heats up, it warms the air above it. This warm air rises, cools with altitude, and forms clouds that may produce short, intense rainfall common in tropical regions. Example, during hot summer days in northern and central India, the land heats up quickly, causing warm air to rise. This rising air cools and forms cloud, often leading to local thunderstorm or pre-monsoon showers. Convergent lifting. When air masses converge, they are forced to rise. Common in low pressure zones like the equator or cyclonic systems, rising moist air cools and condenses to form clouds and precipitation. Example, in India during the southwest monsoon, June to September, moist winds from the Arabian Sea and Bay of Bengal converge over a low pressure area, rise and form rain clouds, leading to heavy rainfall in the Western Ghats, Northeast India and Gangetic Plains. Measurement of precipitation. There are various methods for measuring precipitation. Understanding these techniques is crucial for hydrological studies, water resource management, and civil engineering projects planning. The key methods are direct measurement using rain gauges. Rain gauges are the most common tool for measuring precipitation. They are of the following two types: non-recording rain gauges and recording rain gauges. Non-recording rain gauges measure precipitation over a set period but do not provide continuous data, whereas recording rain gauges offer continuous data on rainfall intensity and duration. The other method is remote sensing, radar and satellite-based measurement. Remote sensing technologies such as radar and satellite provide real-time large-scale precipitation data. Non-recording rain gauges. A non-recording rain gauge, example Simon's rain gauge, measures total rainfall. The Simon's rain gauge is a simple instrument widely used in field stations for measuring total rainfall over a specific period. It consists of a cylindrical collector, a funnel that directs rainwater into a graduated measuring jar, and a metal casing to protect this setup. The water collected is measured manually using the calibrated jar. Recording rain gauges. Recording rain gauges automatically measure and record rainfall over time, providing continuous data. The types include tipping bucket rain gauge, weighing bucket rain gauge, floating type rain gauge, acoustic rain gauge, and optical or laser rain gauge. Tipping bucket rain gauge. Tipping bucket rain gauge automatically measures and records the amount and intensity of rainfall. Uses a small divided bucket that tips when filled with a specific amount of rain, for example 0.01 inches. Each tip triggers a recording. Weighing bucket rain gauge. It measures precipitation by its weight in a collecting bucket. This weight data is converted into a recording of rainfall amount and rate. This method accurately measures all types of precipitation, even heavy rainfall. Floating type rain gauge. Rainfall collects in a chamber, causing a float to rise proportional to the amount of the water collected. The float's motion drives a pen to record rainfall on a chart. It provides a continuous recording of rainfall over time. Acoustic rain gauge. Acoustic rain gauge is a type of rain gauge that uses sound to measure rainfall. Detects the sound of raindrops hitting a surface. Sound intensity and frequency are analyzed to determine rainfall rate and amount. Electronic processing converts sound data into rainfall records. Optical or laser rain gauge. It detects changes in a light beam caused by falling raindrops, analyzes scattering or flickering of light to determine rainfall. Light data is converted then to rainfall amount and intensity. Radar and satellite-based measurement. It is used for large-scale precipitation mapping. Radar detects raindrop size and intensity using electromagnetic waves. Satellites uses sensors to monitor cloud properties and estimate precipitation. Impact of climate change on precipitation. Climate change is reshaping Earth's rainfall pattern. Changes in precipitation pattern, increased intensity, warmer air holds more moisture leading to more intense rainfall events, often causing flash floods. Shifting seasons, the timing of precipitation is shifting. Some regions experience delayed monsoon or altered snow and rain season. More extreme events, there is a rise in frequency of extreme precipitation including heavy downpour and prolonged droughts. Regional variability, wet areas getting wetter, high altitude and equatorial regions are experiencing increased rainfall. Dry areas getting drier, subtropical and some mid-latitude regions are seeing declining precipitation and prolonged droughts. Snow and ice dynamics, more rain, less snow. In colder regions, warmer temperatures are turning snow into rain, reducing snowpack. Earlier melting, snow and glaciers are melting earlier in spring, affecting river flows and water supply during summer. Impact on hydrological cycle, altered runoff and recharge. Changes in rainfall affect surface runoff, groundwater recharge and river flow regimes. Increased evaporation, higher temperature lead to more evaporation, reducing the effectiveness of precipitation. Self-assessment questions. At the end of the presentation, these are self-assessment questions. Go through each question carefully. Answer these questions based on understanding of the topic. Review any concept you are unsure about. The questions are: define precipitation and explain its role in hydrological cycle and civil engineering planning. Discuss the different forms of precipitation and their significance in hydrology and infrastructure design. Compare the four major cloud lifting mechanisms that lead to precipitation. Explain the different methods used to measure precipitation. Discuss how climate change affects global precipitation pattern and how does climate change disrupts the hydrological cycle. What are the consequences for water resources? Note, our next presentation will focus resolving numerical problems related to measurement of precipitation. Thank you for joining this lesson on engineering hydrology today. Hope you found this presentation informative. Don't forget to like and subscribe the channel Dr. A Classes for more engaging lessons on core subjects of civil engineering.